This is lesson 2.8, proving angle relationships. Starting on page 156, find the measure of each numbered angle and name the theorems that justify your work. So in problem number 1, we are given that the measure of angle 2 is equal to 26. We notice that we have a right angle for angle 1. So therefore, the angle on the other side will be a right angle. And these two angles have to add up to 90 by the complements theorem. So the complements theorem says that two adjacent angles whose non-adjacent sides forms a right angle will be complementary. So the angles 2 and 3 are complementary, or adjacent angles that form a right angle. So the measure of angle 2 plus the measure of angle 3 is 90. From here we can substitute in the measure of angle 2, which is 26. So now we have 26 plus the measure of angle 3 equals 90. And if we subtract 26 from both sides, we get that the measure of angle 3 is equal to 64 degrees. So once again, we had to use the complements theorem, which states two adjacent angles who form a right angle will be complementary. In number 3, we are given that the measure of angle 4 is 2x and the measure of angle 5 is x plus 9. So here we'd have to use the supplements theorem because we notice that we have a straight line, which is always 180 degrees, and then we have two angles along that straight line. So adjacent angles whose non-adjacent sides forms a straight line are a linear pair. And the supplements theorem says that linear pairs will be supplementary. So the angles 4 and 5 are supplementary because they form a linear pair. So the measure of angle 4 plus the measure of angle 5 is equal to 180. From here we substitute in what we have for the measure of angle 4 and 5. So we would substitute in 2x for the measure of 4, x plus 9 for 5, and we set that equal to 180. From here we combine our like terms, so 2x and x gives us 3x plus 9 equals 180. Then we would subtract 9 from both sides and get 3x is equal to 171. So divide both sides by 3 and we get x is equal to 57. From here we have to find out the angle measure. So we need to substitute 57 in for x for the measure of 4 and 5. So the measure of angle 4 is 2x, or 2 times 57. The measure of 5 is x plus 9, or 57 plus 9. So our angles are 114 and 66 degrees. And once again, we use the supplements theorem. If two angles form a linear pair, then they are supplementary. For number 5, we want to refer to the diagram of the parking lot. And we are given that angle 2 is congruent to angle 6, and we want to prove that angle 4 is congruent to angle 8. So here's what we are given, here's what we want to prove. So we start by giving some given information, that angle 2 is congruent to angle 6, so that is given. Then we also look at our diagram and see if there's anything that we can write down. Well, we notice here that 2 and 4 form a linear pair, and 6 and 8 form a linear pair. So we can say that the measure of angle 2 plus the measure of angle 4 is 180, and the measure of angle 6 plus the measure of angle 8 equals 180, because those are linear pairs. So by the supplements theorem says that if two angles form a linear pair, then they will be supplementary. So we've just stated that. Now from here, we want to do some substitution. So we're going to take this second equation in step 2, and we're going to take the measure of angle 6 out and put the measure of angle 2 in its place, because in step number 1 it says that 2 and 6 are congruent, so we're allowed to do that. So now this statement, instead of 6 plus 8, reads 2 plus 8 equals 180. Now from here I have two equations that I can subtract the measure of angle 2 from to get an expression for the measure of angle 4 and the measure of angle 8. So if I take this first equation, 2 plus 4 is 180, and I subtract the measure of angle 2 from both sides, then I would get the measure of angle 4 is equal to 180 minus the measure of angle 2. Likewise, if I take the statement in step 3 and I subtract the measure of angle 2 from both sides, so that's what I'm doing right here once again. So that's subtraction property of equality. I'm subtracting the same thing from both sides of the equation. then I would end up with the measure of angle 8 is equal to 180 minus the measure of angle 2. From here, I'd use substitution again. So I notice that I have two things, 4 and 8, which are both equal to the same thing. So I know that the measure of angle 4 is equal to the measure of angle 8. Basically what I did was I took 180 minus the measure of angle 2, and since that's equal to the measure of angle 8, I put the measure of angle 8 in place of it. So measure of angle 4 equals measure of angle 8 through substitution. The last step is the definition of congruent angles. So anytime two angles have the same measure, then we can say that they're congruent by the definition of congruent angles. And this also works the other way. So if it said angle 4 is congruent to angle 8, then it says in the next step the measure of angle 4 is equal to the measure of angle 8. That too would be definition of congruent angles. In this next proof, we want to write a two-column proof where we are given that angle 4 is congruent to angle 7. So those two angles are congruent. And we want to prove that angle 5 is congruent to angle 6. So based off of the given information, this is what we want to prove. So let's go ahead and state some given information. 4 is congruent to 7. Then we look at our diagram and we notice that we have vertical angles here. So 4 and 5 are vertical angles. They are angles, non-adjacent angles who are formed by two intersecting lines. So 4 and 5 are vertical angles. 6 and 7 are also vertical angles. And we know that vertical angles are always congruent. So in number 2, we're going to state that angle 4 is congruent to angle 5, and angle 6 is congruent to angle 7 by the vertical angles theorem. In number 3, we can do some substitution. So we want to arrive at this fact that 5 is congruent to angle 6. So if we take our original statement that 4 is congruent to 7, and for that statement we can substitute 5 in place of 4, because in the next statement it says that 4 is congruent to 5. So if I take 4 out of this statement and put 5 in its place, now I have that 7 and 5 are congruent. And then I'm going to use substitution one more time. So I know that 6 and 7 are congruent. So in the next step, I'm going to take 7 out and put 6 in its place, showing that 5 and 6 are congruent angles. Okay, on number 9, we're back to finding the measure of each numbered angle and naming the theorems used that justify your work. So on number 9, we are given that angle 2 and 3 are complementary. We are given that angle 1 is congruent to angle 4, and the measure of angle 2 is equal to 28. So the first thing, since angle 2 and 3 are complementary, we know that they add up to 90 degrees. From here we can substitute in what the measure of angle 2 is, which is 28, subtract 28 from 90, and we get the measure of angle 3 is equal to 62. In the next part it says that in the figure 1 plus 2 plus 3 plus the measure of angle 4 equals 180, and we can say that based off of oops, sorry about that. So in the diagram we can clearly see that we have 1, 2, 3, 4 angles along this straight line, which is 180 degrees. So by the supplements theorem we know that these 4 angles have to add up to 180. So 1, 2, 3 and the measure of 4 together is 180. From here we're going to substitute. So we have this equation, 2 plus 3 is equal to 90. So in place of 2 plus 3 we put 90, we keep the rest the same. From here we can subtract 90 from both sides, so the measure of angle 1 plus the measure of angle 4 is equal to 90. Also, we know that 1 and 4 are congruent, so the measure of angle 1 plus the measure of angle 1 is equal to 90 because I substituted in angle 1 in place of angle 4. And this illustrates the congruent complements theorem. If two angles are complementary with the same angle, then they will be congruent. So from here we would just simplify. Measure of angle 1 plus measure of angle 1 is 2 times the measure of angle 1. And then divide both sides by 2, so the measure of angle 1 is equal to 45. Now we have to take it back to the original problem and substitute in. So the measure of angle 1 is 45, and therefore the measure of angle 4 is 45. So once again, we use congruent complements and the supplements theorem. In number 11, we want to use the supplements theorem since 9 and 10 form a linear pair, so they will be supplementary. So 9 and 10 form a linear pair. They are adjacent, their non-adjacent sides forms a straight line, so they will be supplementary. So the measure of 9 plus the measure of angle 10 is equal to 180. We're going to substitute in what we have for the measure of angle 9 and 10. So that would be 3x plus 12 for 9 and x minus 24 for 10. Then combine your like terms and you get 4x. Subtract 24 from 12 and you get minus 12. So then add 12 to both sides and you get 4x is equal to 192. Divide both sides by 4 and you get x is equal to 48. From here we want to substitute in 48 in place of x. So the expression for the measure of angle 9 is 3x plus 12. So that becomes 3 times 48 plus 12, which is 156. The measure of angle 10 is x minus 24, so 48 minus 24, which is 24 degrees. And once again, we had to use the supplements theorem to set this problem up. For number 13, the measure of 6 is 2x minus 21, and the measure of angle 7 is 3x minus 34. So in this case, the measure of angle 6 plus the measure of angle 7 equals 180, and the measure of angle 7 plus the measure of angle 8 equals 180. So these two angles will add up to 180 because they form a linear pair. Likewise, these two angles will add up to 180 because they form a linear pair. So that is the supplements theorem to get started. It goes on to say, since 6 and 8 are vertical angles, they are congruent, which is the vertical angles theorem. So 6 and 8 will have the same measure because they are vertical angles. So since 6 and 8 are vertical angles, they are congruent. The measure of angle 6 is equal to the measure of angle 8. The measure of angle 6 plus the measure of angle 7 is equal to 180. So we can substitute in what we have here for the measures of 6 and 7. So for 6 we have 2x minus 21. For 7 we have 3x minus 34, and that's equal to 180. We combine our like terms, we get 5x minus 55. We add 55 to both sides, and we divide both sides by 5. So x is equal to 47. Now from here, we actually want to find our angle measures. So we're going to substitute x equals 47 in for the measure of angle 6. So the measure of angle 6, which is 2x minus 21, becomes 73. So since 6 is 73, 8 will also be 73 because it is a vertical angle with angle 6. We also know that the measure of angle 6 plus the measure of angle 7 is equal to 180. So 6 plus 7 is 180 because they form a linear pair, so that is the supplements theorem. Therefore, 6 is 73, so substitute in, subtract 73 from both sides, and the measure of angle 7 is 103. So here we use the congruent supplements theorem and the vertical angles theorem. Okay, for this next one, number 15, we want to write a two-column proof. We're given that 5 is congruent to angle 6, and we want to prove that 4 is congruent to angle 6. Or I'm sorry, that 4 and 6 are supplementary, that they add up to 180. So the first thing that we're going to do is state our given information. 5 is congruent to angle 6, and there was a typo here, so I had to change 4 to 5. So angle 5 is congruent to angle 6. That is given. If that is given, then we can say that their measures are equal by the definition of congruent angles. So anytime we say that angles are congruent, we can say that their measures are equal by definition of congruent angles. From here, we're going to use the supplements theorem. If we look at our diagram, we notice that 4 and 5 form a linear pair. Okay, they are adjacent angles along a straight line. So if they are a linear pair, then they are supplementary. So 4 plus 5 is equal to 180. That's the supplement theorem. From there, we can use some substitution because we're wanting to get 4 and 6 together. So since we know that 5 and 6 are equal, we can substitute those for each other. So if I take statement number 3, I leave 4 alone, but in place of 5 I put angle 6. Now I'm going to have 4 plus 6, or 6 plus 4, which is what I have in statement number 4. So I substituted in that step. And since 6 plus 4 is 180, then by the definition of supplementary angles, 4 and 6 are supplementary because we just showed that they added up to 180. So that is the definition of supplementary angles. If they add up to 180, then they are supplementary. In number 17, we want to give a proof for the complements theorem. So the complements theorem states that two adjacent angles whose non-adjacent sides forms a right angle will always be complementary. So the first thing that you would need to do is make a diagram where you have some adjacent angles whose non-adjacent sides forms a right angle. So we are given that ABC, in other words, is a right angle, but we want to prove that 1 and 2 are complementary angles. So let's state our given information. Angle ABC is a right angle. That is given. If it is a right angle, we know by the definition of a right angle that its measure is 90 degrees. So in statement 2, the measure of angle ABC equals 90. Definition of a right angle. Now this could also go the other way. If we stated that the measure of angle ABC equals 90, and then we said that angle ABC is a right angle, our reason would still be definition of a right angle. From here, we're going to use the angle addition postulate, which is a lot like the segment addition postulate. So I'm adding two parts together to get the whole. So if I take the measure of angle 1 plus the measure of angle 2, well, that's going to be equal to the measure of the entire angle. The measure of angle ABC is equal to the measure of 1 plus the measure of angle 2. From there I can substitute. So I'm substituting 90 in for the measure of angle ABC because in statement 2 it says that they are equal. So I'm getting this new statement by taking the measure of ABC out and putting 90 in its place. And then finally, I can say that angles 1 and 2 are complementary because I just showed that they added up to 90 degrees. So two angles that have a sum of 90 are called complementary angles. And that's just by the definition of complementary angles. In problem number 19, we want to prove the transitive property of angle congruence. So the transitive property of angle congruence states that given angle A, or angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 will be congruent to angle 3. So a part of this proof is the transitive property of equality, but it's different from the transitive property of congruence because it deals with equal statements, not congruent statements. So the first thing that we'd want to do is state three angles. So we draw our angles. This is what we're given. This is what we're trying to prove. And then we set up our statements and reasons. So our first statement, we're going to state the given information. Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Based off of this information, we can say that the angles have the same measure by definition of congruent angles. So, if angle 1 is congruent to angle 2, then the measure of angle 1 is equal to the measure of angle 2. If angle 2 is congruent to angle 3, then the measure of angle 2 is equal to the measure of angle 3. Once again, that is the definition of congruent angles. That is our reason for that part. From here, now we're going to use the transitive property, and this should say of equality. A transitive property of equality states that if A equals B and B equals C, then we can say that A equals C. So in this case, 1 is congruent to 3 because 1 is congruent to, or 1 is equal to 3 because in the previous step it says that 1 is equal to 2 and that 2 is equal to 3. So here's my A, my B, and my C. A equals B, B equals C, therefore A equals C. So that's the transitive property of equality. And then finally we use the definition of congruent angles again because we just said that they have the same measure. Since they have the same measure, then we can say that the angles are in fact congruent. So angles that have the same measure will be congruent angles by the definition of congruent angles.